In this part of the video, we will discuss about three reactions: aldol condensation, cross-aldol condensation, and Cannizarro reaction. As you can see, some of the questions are mentioned here. So question number 1, 2, 3, and 4. All these four questions are basically having the same answer. So we will look into solving these four questions first. These four questions: what is aldol condensation? Explain the example, or how will you convert acetaldehyde into crotonaldehyde or butylenol. This is the structure of acetaldehyde, and crotonaldehyde and butylenol are basically the names of the same compound. This is the structure of butylenol. If you see, you can number the chain, and you will find that there are four carbons in the chain. So that would be the parent but, and on the second and the third carbon you have a double bond. So you are going to put its position, that is BO2, in, and this particular functionality is aldehyde. Therefore, you are going to put Al at the end, and that would be the name butylenol. It is also commonly known as crotonaldehyde. One more thing which can be noticed here is the starting compound has two carbons, but the product has four carbons. So it is a kind of condensation of two units of acetaldehyde, which is giving us butylenol. So we will go and look into more details now. Aldol condensation. In the presence of dilute base, aldehydes and ketones containing alpha hydrogen atom react to form beta hydroxyaldehyde or ketone in the first step, and loss of water molecule in the second step produces alpha beta unsaturated aldehyde or ketone. So basically the key word here is that they should be containing alpha hydrogen atom. As far as the function group is concerned, this is the function group of the compound, and next to the function group, this particular carbon is alpha carbon, and on this alpha carbon there are three hydrogens, which we can call them as alpha hydrogen atom. And any aldehyde or ketone containing such alpha hydrogen atom can give us aldol condensation. We will look into the simple equation of this aldol condensation. Basically, what we need is two aldehyde molecules. So I am putting two molecules of aldehyde together, and what is going to happen is they are going to condense with each other. That is aldol condensation. And if you see the product here in the presence of dilute NaOH, this is the first step of the reaction. Apparently, what you can notice here is that this particular CH3 is now in the form of CH2. So one hydrogen has been removed, and do remember that this is the alpha carbon and it is containing alpha hydrogen atom. So this hydrogen atom is taken out by the base, and a carbanion is generated, and that carbanion will be attacking on other molecule, and then this addition product is formed. And on heating, this compound is losing water, OH and H is lost, and what you are getting is generation of double bond. In this molecule, double bond is between the second and the third carbon, or you can number it as alpha and beta. So these kind of aldehydes or ketones are called as alpha beta unsaturated aldehyde or ketones. This is the final product, and its name is butylenol, also known as crotonaldehyde. We will look into the details of the mechanism in the next slide. So mechanism is like this, that we have an aldehyde with alpha hydrogen atom, and we have a base OH minus, which will take out the proton from this molecule. When you make one, you break one, and the bond is shifting on this single bond. At the same time, oxygen double bond is going to open up in this fashion. So what you are going to get is CH2 double bond CO minus. In certain books, what we can do is the loss of proton is shown in this fashion, that bond is going on CH2, and it can be written as CH2 minus and C double bond O and H. However, this minus charge can again resonate in this fashion, and it will lead to this inorate form. Okay, basically both the structures are having negative charge, and in one of the structure negative charge is on carbon, in the other structure negative charge is on oxygen, and it is more favorable on oxygen, hence we don't write minus charge on the CH2. We show directly the transfer of bond in this fashion, that oxygen is receiving the negative charge. In the second step of the reaction, we have another aldehyde. So basically, we have used two aldehyde molecules. One of the molecule of aldehyde we have transformed into the inorate form, and now the second aldehyde I am taking, which is shown in red here, and our inorate will attack on this. As far as the polarities are concerned, carbon is electron deficient, and that electron deficiency can be used in this reaction. So what will happen is O minus will delocalize the minus charge, and bond will open up, and it will attack on C double bond O system, and the bond of oxygen will again open up. What you are going to get in the presence of water is CH3 CHOH. This particular oxygen is supposed to be in O minus form, but it is taking up proton from water. So we are not writing it as O minus, we are writing it as OH. And the remaining part is just copied by following the arrows, that O single bond is becoming now O double bond, because we have shifted the charge, right? So this is the beta hydroxy aldehyde which is formed, and on heating it will lose water, and we will be getting alpha beta unsaturated aldehyde in this case. The loss of water is taking place by conjugate base mechanism, which is called as E1CB mechanism. That is, first OH minus is taking out a proton from CH2, that will become CH minus, and then minus will push away OH, and in this fashion loss of water takes place. So that second step, dehydration, is basically occurring through E1CB mechanism. E1CB. For the sake of more practice and having a clear idea of the whole Aldol condensation, we can have another example. In this case, we are taking propanol. What is the action of NaOH on propanol? So we will write the structure of propanol, CH3, CH2, C double bond OH, and this particular alpha carbon has alpha hydrogen also. In the presence of base, it can definitely undergo aldol condensation. The second question is also related to propanol again. And what we are supposed to do is we are supposed to prepare pen-2-enol, 2-methyl pen-2-enol from propanol. So what we will do is make a 5-carbon chain, number it 1, 2, 3, 4, and 5. put a double bond between second and third carbon and a methyl group again on the second carbon, and that will give us our molecule, that is CH2, CH3, and in this case here it is CH. So this is what we are supposed to prepare from propanol. You can see that there are in total 6 carbons in this molecule, and propanol has 3 carbons. So there is a condensation which is taking place. 3 plus 3 is giving us a 6 carbon system here. So let us solve this question. What is the action of dilute NaOH on propanol? We will write the structure of propanol. And please do remember that after the functional group, this is the alpha carbon and this is the beta carbon. Also remember that aldol condensation is given by the aldehydes and ketones which are containing alpha hydrogen atom. So basically this hydrogen atom which is present on alpha carbon is very important. Usually the common mistakes which students do is they just remember the first example, that is acetaldehyde, where we are removing the proton from CH3, right? In the previous example we have seen. So most of the times students tend to remove proton from beta because it is CH3. So that is not the case. We are not removing proton from CH3. We are removing proton from alpha carbon atom. That is the carbon atom which is next to the functionality. So in this case, our alpha carbon atom is CH2 in form and not it is CH3. Okay. So let us focus on this alpha carbon atom, and we will write this alpha carbon atom with extended hydrogen. So it is again the same molecule rewritten to show this hydrogen which is alpha separately. So we can use it in the mechanism and we can remove H from this particular alpha carbon. Okay. So base will come, base will abstract the proton. When you make one, you are shifting that bond on that side, that is break one, and oxygen bond is opened up. These are the 3 concerted steps, let us say, which is happening in this case, and what you are going to get is an inorate form of your aldehyde. Now for aldol condensation, we need another molecule. So what we will have is the next molecule, again propanol molecule, and the polarity is known to us that this particular carbon is electron deficient, containing delta plus charge, and this is the inorate form. Again, we will attack by this O minus and shift the double bond towards carbon and open the carbon oxygen bond. We will be getting addition product where this red CH is now connected to the carbonyl of the other molecule. Bond has opened up, and in the presence of water it is now written as OH because it has taken a proton from water. Then heating will give you dehydration and loss of water, and it will be the formation of our target molecule. So this is how you can write the aldol condensation with different kind of aldehydes or ketones if asked. Now the total reaction can be written as a hydroxy compound losing water to give you alpha beta unsaturated aldehyde, and in this case it is 2-methyl pent 2-enol. Now what is cross aldol condensation or mixed aldol condensation, or it can be asked with a different fashion, in a different fashion, like what, how will you convert ethanol into 3-phenyl prop 2-enol? If you just write the structures of these names, then you will realize that it is mixed aldol which is being asked from you. 3-phenyl prop 2-enol. How many carbon chain I will need? For propane, I will be needing 3 carbon, and it is an aldehyde with double bond at the second carbon, right? And on the third carbon, I need phenyl. So this is the structure of our product. I will balance the hydrogens, H and H again. So this is what we are supposed to prepare. From ethanol, we are supposed to prepare this compound. As you can see that this part is different, right? And this part is coming from your ethanol. So it is like using two different aldehydes and doing aldol condensation. When such a situation is taking place in an aldol condensation that aldehydes are different, then it is called as cross aldol or mixed aldol condensation. Cross aldol, a mixture of two different aldehydes. When treated with dilute base, the reaction is called as cross-aldol. Such reactions give better yields if only one of two aldehydes used in the reaction have alpha hydrogen atom. Okay, so if a mixture of benzaldehyde, which is not containing alpha hydrogen atom, and acetaldehyde is reacted, we'll be getting a nice cross-aldol condensation reaction. We will write the benzaldehyde structure and we'll write your acetaldehyde. And condensation, if you see, basically is nothing but joining them together and generating a double bond by loss of water. Water is lost, as you remember in the previous example also. So this oxygen is lost along with that water, and you can simply write the intermediate first, as we know that this is alpha hydrogen atom, which will be removed from this carbon, and this will become CH2, and it will attack now on this particular carbon of aldehyde, and the bond will open up. So we write it as the hydroxy aldehyde product, and then loss of water will be giving you a double bond. So that is what will happen in this reaction. Acetaldehyde or ethanol can condense with benzaldehyde. Okay. So what we will do is write the mechanism now. We take acetaldehyde, we have the base, we take out the proton, bond opens up. We are showing this in the negative charge with carbanion form. You can make enolate also, right? You remember enolate? CS2 double bond C O minus and H, right? So it's another form is enolate. You can use either of the form. I am showing both of them. In the previous example, I have shown through enolate. So what will happen now? Your carbanion will attack here on this other carbon. When you make one, you break one. We'll be getting addition product where benzaldehyde's oxygen is opening up and it is becoming OH. And on heating, it will lose water and a double bond will be generated between alpha and beta carbons. So we get this particular compound, which is known as 3-phenyl prop 2 enal, and its another name is cinemaldehyde, CINNA, cinemaldehyde. The reaction which we are supposed to look into in this video is Cannizarro reaction. What is Cannizarro reaction? Explain an example. What is the action of concentrated NaOH on formaldehyde or methanol? It is also known as methanol. Fine. So Cannizarro reaction is sorry is a reaction in which uh, what happens that aldehydes which do not contain alpha hydrogen atom, they are undergoing Cannizarro reaction. There is a redox reaction which is taking place for such aldehydes. One mole of aldehyde will get oxidized and the other mole of aldehyde will get reduced. I will just show the example and then we will discuss more. This is formaldehyde or methanol. As you can see that it has the function group, but there is no carbon next to the function group, so there is no alpha carbon. And when there is no alpha carbon, there will be no alpha hydrogen as well. So this is aldehyde which is not containing alpha hydrogen atom. And such aldehydes can give us Cannizarro reaction. Okay. As per the description, what happens that one of the molecule will get oxidized and one is reduced. As we know the reduction, basically what we can assume that this particular C double bond O functionality can get reduced and hydrogen can be imagined to be getting added across this double bond. So we are adding hydrogens here, and what will happen is you are going to get these two hydrogens across the double bond getting added, and we are getting an alcohol. Okay. This is happening in the presence of concentrated NaOH, like more than 50% concentrated NaOH solution. What about the other aldehyde? In the other aldehyde, oxidation is taking place. As we know that oxidation product is supposed to be an acid from aldehyde, that is C double bond O H becomes C double bond O OH. But the base is present, so this acid which is formed, as soon as it is formed, it will react with the base, it will form the salt. So the product is not written as acid, but it is written in its salt form like ONA. So this is what is happening in the whole reaction. So what is the total reaction? One molecule is getting reduced to alcohol and one molecule is getting oxidized to acid, and this reaction is called as Cannizarro reaction. Okay, but this reaction, if you see the mechanism wise, there is a hydride shift or H minus shift from one of the aldehyde towards other aldehyde. So let us see some more details of the mechanism now. Cannizarro reaction mechanism. So this is the aldehyde which we have taken. There are two aldehyde molecules which need to be used in this mechanism. The first one is taken here and OH minus will be attacking on this carbon. When you make one, you break one of course, and you are going to get an addition of OH across the double bond. Bond has opened up, so oxygen will be having now a minus charge. Now we are supposed to shift a hydrogen in the form of hydride towards the other aldehyde. So what I'm going to do is bring another aldehyde, and what we will do is close the O minus charge to make the double bond, and when this is closing down, it will push away H minus towards the other aldehyde. So basically this arrow is showing that this hydrogen is shifting on the neighboring aldehyde with both the electrons. So both the electrons of the bond are moving along with hydrogen. So this hydrogen is basically moving in the form of H minus ion. Okay, so H minus is attacking here and the bond opens up. Let us write the next step. So what you can notice here is oxygen was closing the minus charge to make the double bond. So this oxygen will have double bond O, and this is the OH which is present here. Okay, and what has happened to the other part? That is hydride has been added across the carbonyl group. So this is the H which is coming from the other aldehyde, and you will have O minus. Now basically this is an acid which is easily giving away H plus ion because it is an acid, and this methoxide, that is CH3O minus, can basically accept the H plus ion from acid in this fashion, and what we will write is methanol plus the salt of acid. So if electrons are coming on this oxygen, so it will be O minus, which will be balanced by Na plus, and this is how we show the completion of the reaction. So this reaction is called as Cannizarro's reaction. It is also called as disproportionation reaction. one molecule is getting oxidized and one molecule is getting reduced. And this is happening for only those aldehydes which are containing alpha hydrogen atom. For the sake of some more practice, what you can do is do the same reaction with benzaldehyde. What is benzaldehyde? You know, you need a benzene ring and C double bond O H group on it, and we have another aldehyde which is 2,2-dimethyl propanol. How many carbons I need for propanol? I need 3 carbons for propanol. I'll put C double bond O and H. I will number the chain, so that is propanol. On the second carbon, 2,2-dimethyl. So I will put 2 methyls on this second carbon, balance the remaining carbon. And what we realize that it does have alpha carbon atom, but it does not have any hydrogen on it. All the three substituents are methyl here. So this is an aldehyde which is not containing any alpha hydrogen atom. No alpha hydrogen atom here and no alpha hydrogen atom here. As you can see that this carbon is not containing any hydrogen, and this is the alpha carbon. So basically both these two aldehydes, both aldehydes can give a Cannizarro reaction, and they will not be able to undergo aldol condensation reaction. I hope you will practice with these two structures and try to get a better idea of what is Cannizarro's reaction. So we have basically seen all these three reactions: aldol, cross aldol, and Cannizarro's.